To pre-calculus on Friday, May 5th, 2017. That would be a horrible way to start these, wouldn't that be? Should I talk like that every time I give a lecture? All right, let's go do limits. Limits are a way of approaching a value without actually touching it. So, you guys remember if you say the limit as x approaches 1, you're saying as you approach 1, but you don't actually get there. And I don't know who it was that I gave this awkward situation to, but did I make one of you guys walk toward each other? Do you remember that was?
Oh, yeah, it was
Who was it?
Claire.
Claire and Adam. So they walked toward each other, and then you get infinitely close without touch. The idea of a limit is like you walk halfway towards something with progressively halfway, halfway, halfway. Well, you'll never actually get there. You can get infinitely close to something without touching it. A limit is getting infinitely close without touching. So when I look at this graph, the first picture is the graph. Doesn't it look like a rational expression, like it should be all fancy and have weirdness in it? If you remember, we factor those. That'd be what, x plus 5x minus 2 on top. And if you write x plus 5, x minus, that didn't work out. X plus 5 times x minus 2. And the bottom's x minus 2. There is a cancellation, and you all know that x cannot be 2, and that's a whole, spelled U-H-H-O-L-E, at 2. So right over here. Right there. That is important because when you're done canceling, this is the graph that you see, x plus 5. We can see it over there. There's the picture of it. The difference is it has a whole at x equals 2. If I were to write a limit that I can't evaluate the function at 2, like f of 2 doesn't exist. A whole is a place that just literally isn't there. So that's what you guys saw in yours. But if I say what's the limit as x approaches 2, that means if I were to get close on either side, what a limit is always a height. It's where you're headed. So as x approaches 2, the question came up, what about the plus or minus? This is what's called a general limit. It means from both sides. What does the limit as x approaches 2, what's the function headed toward? And we all know it's headed to 7. You can see the height is 7. So limit is not getting there, because if I got there, I'd have a does not exist scenario, but I'm getting there. At least I'm getting infinitely close to there. I'm headed towards 7. Everybody knows the height is at 7. That ends up being like the whole premise of limits, is that you can't go to certain spots, but you can talk about what height you're headed toward as you get there. So now down below, there's some blanks on there that I actually can't really remember what goes in there because somebody wrote them for me. But f of negative 3 on the first one, you ready for your guess check? On your marks, get set. Did you write 4 and 4 for the first one? Yes! And if you didn't, it's okay, but the guess is if you put negative 3 in, you get out 4. This is the point, like the solid dots. The other one is like what height are you headed toward as x approaches negative 3? They're the same, and this is true for any continuous function. It makes limits look really dumb when you do it on a continuous function. And I don't know how if I spelled that, but continuous functions, the limit is the same as x approaches 3 is the same as putting 3 in, or negative 3. But if a whole is there, the point doesn't exist. Now you can use DNE or you can put that little empty set thing. But as I approach negative 3, I can evaluate the limit in the second one, but I cannot get the point. That is a huge, very, very, very small statement. Those two problems, just look at those. That makes the importance of limits known because you realize I can't plug in the point, but I can talk about where it's at, generally speaking. So, Nick, Sydney, hey, psst. So now, if I do the next one, do you see that weird, the third one? There's that weird point dangling there. Did anybody get f of negative 3 is 1. It's the point. And then the limit, though, it's 4 again. Because the two, as you approach negative 3, but not actually getting to negative 3, the height you're headed toward on the function. So here's the deal, is you're tracing your hand in from both sides, and you're imagining where would I be headed to? What height am I going toward? And it is, limits are about kind of tracing your finger along the function in various directions. Then there's the last one. Last two. These are different. Now the function at negative 3 is go to the solid dots. You're deciding, is it 4 or is it 1? But you look for the solid dot. 1. The limit, though, from the left and the right, you get different stuff. Okay, so different stuff. Check this out. From the left, it's going to a height of 4. From the right, it's going to a height of 1. Those do not agree, so we say the limit does not exist. The limit does not exist. We often, limits we really do write DNE. But that's because I don't know what height it's, is it 4, is it 1? A limit is only known if you have a specific value that you're headed toward, and it's ambiguous at that spot. Then, next one, f of negative 3, 2. And as you approach negative 3 from the left, it's to the 4. From the right, it's to 1. They don't agree, so the limit does not exist. And she wins the game. Remember that. Okay. That's a huge summary of how, that's graphically how we do limits. That's it. If you have the luxury of graphing any limit you're evaluating, you can always evaluate it just by what height it's headed toward or what point it goes to. So down below, here's some notation that I want you to sit there and ponder. A one-sided limit is the height. I actually know where this one is. Height. A function approaches as you approach a given x value. So I'm going to zoom in a little bit. X value. From either the left or the right. There's the summary of if you approach something. So the limit, as this little expression over here on the right that I'm circling, is expressed right here. The limit of f as x approaches 3 from the left side is negative 1. The key is, you guys look at that little plus or minus sign. When it's a negative, it means from the left. From the negative number side is what it stands for. And that's what's expressed in that sentence to there. And on the other one, as you go down, I'll highlight it in a different color. Let's go reddish. But the second expression is expressed verbally or in words, as you see to the left there. The limit is f of x approaches 3. From the right side is 2. It's describing that if you actually go over to this picture, if you come in from the left and trace your fingers, the height you're going toward is negative 1. Versus if I come in from the right side, the height I head to is 2. And if the notation in here, the little plus or minus sign is an indicator from the right. Okay. That's a summary of that left and right stuff. There's one more that's not on here, and it should be, so will you jot this with me? If it just says the limit as x approaches 3 without a plus or minus of f of x, this one does not exist because that's the general limit, the one that we were evaluating in those problems that you guys just guessed on. Without a sign at all, it's called the general limit. It means you have to think of both. So that's a huge deal. This is the general limit, general limit, from both sides. And that's either they go to the same height, or if they go to different heights, it doesn't exist. Cool. That's a big one. There you go. That's kind of limits in a nutshell, the stuff we did before. On the flip side, though, there's some algebra that we have to get involved with, and that's what we're going to do in the next, couple minutes before the bell rings. Let's get there. Roll, scroll, scroll, scroll. All right, turn the page. So you got this example. No! Wait! Get back! You have to watch this. You hang on. Okay, check it out. So as you go through each one of these and you're looking at the graph, the thing that I'm going to write in on these is what type of limit it is before you guys go and look at it. You have to immediately look for those plus or minus signs. Like this is from the left. We'll call this we'll go, anything that's from the left I'll write in blue. Left, from the left. The limits that are from the left-hand side means you'll trace in from the left-hand side. Anything from the right has a plus sign in the limit, and it means you're going to trace your finger in from the right. There's a right, there's a right, there's a right. I don't see any other rights. Everything else that doesn't have a plus or a minus is a general limit. Means you have to look at both. So you're looking at both. The general limits, you look at both directions, both. And your answers either goes to the same height or they go to different heights and it doesn't exist. All right, rock and roll. So both, 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 both. And the last one isn't either one of those, so it gets its own special color. Let's put it in like pink. Oh, we like pink. That's a point. It's not a limit at all. In the picture to the right, you guys want to go ahead and try and evaluate those. I'll catch up with you in just a second, and we'll evaluate those. So you give it a shot. We'll catch up.